All right, welcome. So today we're going to be working with 3.4 graphing ratio relationships. Our standard is 6th grade number sense A, and your objective is that you will be able to represent ratio relationships in a coordinate plane. Mathematical literacy, we have ratio, equivalent ratios. I repeated that twice. Coordinate plane, y-axis, x-axis, vertical, horizontal, and origin. Let's go ahead and get started. All right, so to begin with 3.4 graphing ratio relationships, our success criteria is that by the end of this lesson, you're going to be able to create and plot ordered pairs from a ratio relationship, and also to create graphs to solve ratio problems, and to create graphs to compare ratios. Let's go ahead and get started. All right, so for a mathematical literacy, I'm saying vocabulary words. We have the coordinate plane, which is basically a flat surface that's formed by the intersection of two lines. So we can call them axes. Now, one of the two lines is the horizontal number line, side to side, left and right. That's known as the x-axis. And the vertical number line, known as the y-axis. Okay. So the x and the y-axes, they intersect, meaning that they cross perpendicular at the origin. In other words, the origin means the beginning. So the origin is basically this ordered pair where you have your x-axis and your y-axis. The origin for the x-axis is 0, and the origin for your y-axis is 0. That would be located right there, the origin. Again, the beginning. You always start from the beginning. Now, there's 4 quadrants. You have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Now, if you look at the x-axis, they're positive numbers. The y-axis has positive numbers. So the quadrant 1 is both positive for your x-axis and y-axis. Quadrant 2, your x-axis is negative, your y-axis is positive. Okay. Quadrant 3, your x-axis is negative, and your y-axis is negative. Quadrant 4, your x-axis is positive, and your y-axis is negative. All right. If your x-coordinate is positive, you move right from the origin. If your x-axis is negative, you move left from the origin. Okay, so if the x-coordinate is 0, then you stay at the origin. Again, if your y-axis, your vertical number line, if your y-axis is positive, you move up from the origin. If your if your y-axis is negative, you move down from the origin. And if your y-coordinate is 0, you stay at the origin. Okay. Now, ordered pairs, we're talking about your x-axis and your y-axis. Okay. Ordered pairs, think of these as ratios. Now, your x-axis, I'm going to label that as a blue color, and your y-axis coordinate, we're going to label that as a purple color. All right. So let's go ahead and work on some examples. Here we go. All right, so for this example, we have the x-axis, that is the blue number line here. That is the horizontal number line. Again, horizontal means left to right, side to side. And then in purple, we have the y-axis, that is your vertical number line, straight up and down. Again, right here in the middle where the x-axis and y-axis intersect, we call that the origin, the beginning where you will always start. So in blue, I'm going to write the x-axis here for the ordered pairs, and I'm going to change the color from purple to red, so that way it's a bit more definite that you can see. Okay, so here's your ordered pairs. Now let's listen to this carefully. So we're going to plot and make a ratio here, and plot that ratio on this coordinate plane. So we're going to graph the ratio on the coordinate plane. So an airplane travels 300 miles per hour. So that means that an airplane travels 300 miles per, I guess you can put a ratio here, per every 1 hour. So let's say in 2 hours, that airplane will travel 600 miles. Okay. In 3 hours, that airplane will travel 900 miles. Okay, so our ratio table is there. And if we do this, making it into an actual table, we have our ordered pairs, your x-axis and your y-axis. Now, when we plot this, we're going to go on your x-axis, we're going to go to the right because 300 is a positive number, so we're going to go right on your x-axis. So we're going to go 1, 2, 3, and then go up 1. So there we go. This will be 300 miles to 1 hour. And then we're going to plot the second point. So we're going to go 600 on the y-axis and go up 2. So count 1, 2, 3, 4, 5, 6, 1, 2. So this will be 600 miles to 2 hours. For the third one, we're going to go to 9. So here we're at 1, 2, 3, 4, 5, 6, 7, 8, 9, and go up 3. 1, 2, 3. So this will be 900 miles in 3 hours. Just for fun, in 4 hours, how far will we go? So in 4 hours, so 3, 6, 9, 1,200 miles. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and go up 4. 1, 2, 3, 4. Okay, and we plot there. So now I'm going to take this ruler and use the straight edge here to make a nice straight line. All right, so I'm going to make that straight line there. And then I'm going to connect all the points. So there you have it, my friends. We just graphed the ratio 300 miles per hour that our airplane travels. We made a ratio table and graphed those ratios on the coordinate grid. Let's move on to another example. All right, so moving on to the next example, we're going to graph ratio relationships. Now, in the first column, which is your x-axis, we have flowers, but the measure is in cups, a liquid measure. And then for the y coordinate, in other words, the denominator or your second quantity, we have water in the liquid measure in cups. Okay. Now with this ratio relationship, we see that we have 4 cups of flour to every 2 cups of water, and 8 cups of flour to 4 cups of water, 12 cups of flour to 6 cups of water. Okay. So what we're going to do with that is, if it helps, we can write all the x coordinates here and all the y coordinates there. So let's write all the x coordinates. So we have 4, 8, and 12, and all the y coordinates 2, 4, and 6. Okay. So these are still ratios. Again, the measure is in cups, but to make them into ordered pairs, we're just gonna keep them there. So we just put parentheses around them and to pretend that the only thing in the middle is just a comma. Now from here, we're going to go ahead and plot this onto our coordinate grid. Remember, the x-axis here is your horizontal number line. It goes left to right. Your y-axis is your vertical number line, up and down. So we're always going to start with the x-axis. So all these are positive. All these coordinates are positive. So for the first thing we're going to do is we're going to go to the right 4 times. So 1, 2, 3, 4. And then go up twice. 1, 2. So we're going to plot our point there. And this is going to be 4 and 2. 4 cups of flour to 2 cups of water. All right, let's do another one. The next ordered pair, we have 8 to 4. So 1, 2, 3, 4, 5, 6, 7, 8, and go up 4. 1, 2, 3, 4, and plot that point there. And this is going to be 8 to 4. 8 cups of flour to 4 cups of water. Next, we have 12 to 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and go up 6. 1, 2, 3, 4, 5, 6, and plot there. This is going to be 12 cups of flour to 6 cups of water. Now, these are all equivalent ratios. All right, the next thing we're going to do, and remember, you always start from your origin, right there where your x-axis and y-axis intersect. And then you're going to try to find like if you have a ruler, or you can do some tricks. Like for an example, you can take some paper and just fold it in half and use this part as a straight edge to make a nice straight line. Okay, maybe that would help out a bit. So we're gonna go ahead and connect all of these and connect it to the origin down here and connect it to the last dotted plot there. Go a little bit further out and put an arrow there because this is going to keep going. And there, my friends, you have graphed the ratio relationship between cups of flour to cups of water. All right, let's move on to the next example. All right, from here, it's pretty much the same thing. Again, you're going to be comparing cashews in pounds to how much do they cost in dollars. So for our x-axis, we're going to plot that there, and our y-axis for our ordered pairs. Okay, comma in the middle. Now, for the cashews, we have, let's see, organize everything. For the cashews, we have, for every 1 pound, that is going to cost us $12.50. Okay, and if we get 2 pounds of cashews, we just double that. Okay, oops. 2 pounds of cashews, it's going to cost us $25. If we buy 3 pounds of cashews, that will cost us $37.50. Because if you think about it, if it costs us $12.50 a pound, we're buying 3 pounds. Okay, add them. 0, 5, 10, 15, 2, 4, 6, 7, 1, 2, 3. That's going to cost us $37.50. Okay, so this is what it represents. Again, every 1 pound is going to cost us $12.50. If we buy 2 pounds of cashews, it's going to cost us $25. If we buy 3 pounds of cashews, it's going to cost us $37.50. Now, all we got to do now that we have our ratio table here, but it's represented as in the ordered pair form, we're going to plot that now into our graph here on the coordinate plane. So we always start with the x-axis, and you always start from the origin, the beginning. Now, if you look at all these ordered pairs, every one of these coordinates is positive. So we're always going to go to the right and up. Okay, so we're going to go over 1. For 1 pound, it's going to cost us $12.50. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and a half. You could plot it there, but this is going to be a really steep incline. If you don't have enough space, what we can do is we can maybe use this in increments of 5. So let's say 1, and this is 5, 10, 15, so 5, 10, so 12 and a half would be somewhere in here. So this would be 1 pound is going to cost us $12.50. Now, what about 2 pounds? 1, 2, and then we're going to go up 25. 5, 10, 15, 20, 25. 2 pounds will cost us $25. And then the third one, if we buy 1, 2, 3 pounds of cashews, how much will that cost us? So 5, 10, 15, 20, 25, 30, 35, and 37 and a half, right in the middle. So 3 pounds will cost us $37.50. All right, there you go. And again, find a really nice piece of paper, fold it in half, and use that straight edge to connect the origin to the very last plotted point there, and extend that out. And there's your graph. So we can take it a step further and label this coordinate grid. So the x-axis represents cashews, but in pounds. Cashews in pounds. Okay. And your y-coordinate will be cost, but in dollars. So we're working with currency there. So there you go. Let's from now on also label the axes. All right, that way we know what we're looking at. Okay, so any questions, please let me know. Let's move on. Okay, so for this example, we're gonna model real life. Now we have a hot air balloon that rises 9 meters every 3 seconds, a blimp that also rises 7 meters every 2 seconds, and we want to graph this ratio relationship in the same coordinate plane, and we want to know what rises faster. So again, the hot air balloon rises 9 meters every 3 seconds. In 6 seconds it rises 18 meters, and in 9 seconds it rises 27 meters. The blimp rises in 2 seconds 7 meters. In 4 seconds it rises 14 meters, and in 6 seconds it rises 21 meters. Okay. Now you all hopefully know what a hot air balloon is and what a blimp is. It's like, like when a football game's going on in the NFL, those big things that kind of float above the stadium. Well, that would be a blimp. Okay, so from here, I'm going to make this the y-axis. I'm going to make it red this time. And that's going to be our y-axis, the vertical number line. And in blue, I'm going to make the x-axis. So in blue, I'm going to plot the coordinates for the hot air balloon. And in red, I'm going to plot the coordinates for the blimp. All right, so let's go in like multiples of 4 on our for our height. We'll label this our height. And this is going to be in meters. And in blue, we're going to record the time, but in seconds. Okay. So let's start with the hot air balloon. So for the hot air balloon, we're gonna go 1, 2, in 3 seconds. So in 3 seconds it rises 9 meters. So we're gonna go 9 meters. So this will be like 4, 8, and then 9, right about there. So in 3 seconds it rises 9 meters. Okay. Now, let's see here. In 6 seconds, 1, 2, 3, 4, 5, 6, we're going to go up 18 meters. So 4, 8, 12, 16, somewhere in here is 18 meters. So 6 seconds, it rises 18 meters. And we're going to go ahead and go the last one. In 9 seconds, 1, 2, 3, 4, 5, 6, 7, 8, 9, it rises 27 meters. So 4, 8, 12, 16, 20, 24, 28's here, so 27 should be around there. So in 9 seconds, the hot air balloon rises 27 meters. Okay, and then what we want to do is we're going to get that ruler that I had earlier, and we're going to go ahead to use a straight edge and connect that to the origin. And we're going to label that the hot air balloon. Okay. Now in red, I'm going to switch colors. We're going to plot the coordinates for the blimp. So again, in 2 seconds, 1, 2, it rises 7 meters. So here's 4, 8, so 7 would be there. So in 2 seconds it rises 7 meters. In 1, 2, 3, 4 seconds it rises 14 meters. So 4, 8, 12, 16, so right around here. I'll just kind of give that a rough estimate. In 4 seconds it rises 14 meters. And in 6 seconds, 1, 2, 3, 4, 5, 6 seconds, it rises 4, 8, 12, 16, 21 meters. So in 4 seconds, it rises 21 meters. Now I'm going to get my ruler here, and I'm going to connect and go ahead and put that there. And then this one is the blimp. So the question asks us, which rises faster? Let's see here. The question asks us, which rises faster? Does a hot air balloon rise faster, or does the blimp rise faster? And according to this, after we graphed it, it shows that the blimp rises at a faster rate than the hot air balloon. So the blimp rises at a faster rate than the hot air balloon. Now remember, what we're doing is we're comparing two different ratios, and we plotted and graphed both of those ratios on a coordinate grid. Alright, so hopefully this helps. Alright, to recap 3.4, graphing ratio relationships. By now, you should be able to create and plot ordered pairs from a ratio relationship. And you should also be able to create graphs to solve ratio problems. And lastly, create graphs to compare ratios. So hopefully this was helpful. And, reach out. Let me know if you guys need help. Keep up the good work and get those assignments in.